And there it is. It is 11:20. Good morning. Happy Monday morning. I hope you guys had a good weekend. I had such a relaxing weekend. It was just insane. A mug reveal? It's my mug. Were you talking about like mug as in like my mug, like a picture of my face? Very nice, very nice. Ooh, fancy. It is fancy. It was given to me. It was given to my wife as a gift from my mom, and here I am jacking it. You know what I mean? Just, it's mine. All right. So, guys, we have lots to talk about today, so I don't want to stall. I wish we could just hang out and talk about anything we wanted to. We could talk about Mars. We could talk about rovers. We could talk about satellites and wireless internet. Oh my gosh! And we could talk about electric vehicles. We could talk about accelerating particles at close to the speed of light and seeing what's happening. So much happening in this world today, not to mention viruses. But we are going to be talking about hyperbolas today because we don't have a lot of time. So let's get right into it. So what's going on here? Hyperbolas. One way to think about hyperbolas is they're inverted ellipses. So you can think of it as inverted ellipses. Okay, and that's because for an ellipse, we defined an ellipse as being all the points that was the sum of the distances between the foci, right? So a hyperbola, do not call it a hyperbola. Calling it a hyperbola is really nice phonically to spell it, but it's a hyperbola. Okay, a hyperbola is all the points that are the absolute value of the difference. Oh my gosh. So it's the absolute value of the difference of distances from the foci. Okay, so if you only took one thing away from that crazy definition, is that ellipses is defined as being all the points that is the sum of the distances, and a hyperbola is the difference. It's the absolute value of the difference. Okay, so ellipses, sum, right? Sum means adding. So ellipses is all the points where you add the distances from the foci. The hyperbola is the absolute value of the difference of the distances. So you can think of it as an inverted ellipse, because an ellipse is where you add those distances. A hyperbola is where you subtract those differences. And you're going to literally see that subtraction show up in the equation. Okay, so ellipses, right? Ellipses are where we add. So where we add the distance from foci. And then here, right, it's the difference, so we subtract. So that's how you know the difference between an ellipse and a hyperbola is, does it have addition or does it have subtraction? And we'll go over that next class. Okay, so again, ellipses, the big takeaway is that you add the distances from the foci. The hyperbola is, it's the difference of the distances from the foci, which means you subtract. Okay, and it's the absolute value because, again, we want our distances to be positive. Okay. All right, so that's what a hyperbola is in words. Let's take a look at what a hyperbola is in terms of graphics and pieces and parts. Okay. So there's two types of hyperbolas, right? So again, just like ellipses, there's going to be a major and a minor axis. Okay, and we're going to be using the same notation: A, B, and C. A is going to be our major, B is going to be our minor, and C is going to be the distance from the center to the focus. Okay, so again, A is still our major, B is still our minor, and C is still the distance from the center to the foci. Okay, so for example, I might have a hyperbola like this. Now remember, you can think of this as an inverted ellipse. Now, because it's inverted, the foci were inside the ellipse, but this is inverted, so the foci are going to be on the outside of the ellipse. I mean, the outside, right? So There we go. You can think of it as two parabolas, okay? Because the foci is going to be out here. Now that means my center is in the middle, and my vertices are right here, right? I have two vertices. So I have two vertices, right? And so that means my major axis is going to be left to right. So if I was going to identify some key things here, right? That means the distance from here to here is A, and the distance from here to here is C. Okay. And what we're saying is, if I pick some random point here, if this is D1 and this is D2, then the absolute value of D1 minus D2, right, that equals a constant. Okay, and that's from the definition. So the difference of the from the foci, sorry. The distance from the foci, right? The difference, the absolute value of the difference is constant. That's what's going on there. And again, the distance from the center to the vertex is A. The distance from the center to F is C. And the minor axis plays a really annoying role in hyperbolas. Because what's going to happen here, and I'll draw this in the next picture, what's going to happen here, I can just do it now, I guess, is we're going to have slant asymptotes. And if you've never heard of a slant asymptote, it just means linear asymptotes. Okay, so that's the one new thing, and that's why we're going to spend 2 days on this, is that we have to talk about these slant asymptotes. They're the things that are going to be new. Okay, now this also, because that was a lot to draw in one picture, we'll go over this again. So I also, right, this can open up or down, right? So we could have something like this and like this, right? Where, again, this is my V's and my foci are going to be up and down. So in this case, my A would be with my Y term, right? So in this case, my A would be with my Y term. Okay, here's my center. So again, this would be my A. This would be my C. Okay, and we're going to use the B. So what's going to happen is we're going to use the B. We're going to use the B to make a box, and I'm going to show you guys what that's going to look like in a little bit. Okay, so that's kind of it in a nutshell. You can either have the major axes opening left or right, or up and down. Okay, and I know that's a lot to take in, but it is a lot. And so I'm going to show you all it at once, and then we're going to go back and take a look at it again. And what's going to happen, do you see these corners? This corner of this rectangular box we made? That's how we're going to find our line, our asymptote. Okay, that's how we're going to find our asymptote, is these points in the corner of this rectangle. Because this rectangle is B, it's 2B by 2A. Okay, and we'll take a look at that in a little bit. And I know this is a lot, but I'm just introducing all of it to you so that when we do go over it in more focus, you'd be like, okay, that makes more sense. Okay, so I'm not just going to end here. Okay, so there's two types of equations. Okay, now remember, this is the difference. So for when A is with the major axes, so this is x minus h quantity squared over a squared. Now the difference is, now it's going to be a minus. Okay, so then y minus k quantity squared over b squared equals 1. So notice the only thing difference between a hyperbola and an ellipse is that instead of plus, it's minus. Okay, the other thing that's really important is the major has to come first. And the reason why it has to come first, remember we did the absolute value up here? Well, to avoid using an absolute value down here, the bigger one has to come first because you're subtracting, right? Now you could just keep it like this, but then you'd have to put the absolute value symbol there, and it just complicates everything. So we always put our major term first. So for example here, since the y is the major, you need to write the y first. Okay, So you want to have that in your notes. The major has to come first in a hyperbola. And just as like, and it's not important in an ellipse which one comes first. So I would always drink tea before you say something. No, I would always just put the major term first, because an ellipse order doesn't matter, but as soon as you have subtraction, order matters. So the major has to come first. Okay, so the major has to come first. And remember, the A is still the distance from C to the vertex, and C is still, from the center to the vertex, and C is still the distance from the center to the focus. Okay. How are we doing so far? Are you guys doing okay with this? Am I going too fast? Okay, so these are your basic equations. Okay. Now, I'm going to do something crazy. I'm going to go right into the asymptotes first. Okay, so here are your equations. Now let's talk about asymptotes. Okay, because everything else is the same, right? You still have, I'm just going to write over here, you still have this. Just a second, because I say that and I don't. I don't actually think, just give me a second. Sorry, I'm having a brain fart. So if I look at this, this is A, this is B. So if that's my foci. Okay, we'll get to that later. I don't need that right now. Let's just do this. Sorry, I thought that I was going to add something useful, and I'm like, well, I didn't put it in my notes, so it probably isn't that useful. Okay. Oh, here, I am going to add it. I don't know if this is useful, but this is really confusing. Do you notice how here it's not minus? Okay, so I am going to say it. It's not minus for this, and I'm really sorry about that. They do a derivation of that on page 10, page 717. But just really quickly, I don't know how much we're going to use this. Maybe we will, maybe we won't. But this is different than an ellipse. So it's negative here, it's positive here. So do you see how they switch? So it's a negative here, it's a positive here now. Okay. You guys get that? You guys can give me a sign of life. Okay, there we go. Okay, so now let's talk about asymptotes. Okay. Okay, so this has asymptotes. So there's two ways that the asymptotes are going to happen. I'm just going to draw a couple of pictures to make sure you guys understand, and then we'll talk about how to find them. So again, I'm going to show you these asymptotes two different ways. Okay, so I'm going to do two different coordinate systems. Okay, now we're going to do really easy hyperbolas. So we're not going to do anything too crazy. So because we're doing really easy hyperbolas and we're not doing anything too crazy, it's very formulaic. Okay, so if I have a hyperbola on where the major axis is on the x-axis. Okay, I want to highlight a couple of really important points. Okay, so we have your vertexes and you have this. Now, I didn't draw this very well, but right, this is your A, and this is also, right, this is negative A. And I shouldn't do that. I should say it's the absolute value of A. Okay, so that's a distance A. And then what we have here is up, then we have some distance B and some distance absolute value of B down here. Oops, absolute value of B. I can't write. Now what that creates is it creates this point, this point, this point, and this point. And we're going to use those points to make a rectangle. Okay, do you guys see my rectangle? So again, this total distance here is 2a, and this total distance here is 2b. Okay. To write the equation for our line, all of our lines are going to go through the center, and through those points. So it's going to go through here, here, and here. So to get a line, we always need 2 points. Now, that means you can either get both of these points, but that's going to be a lot of work, or you can use the center and one of these points, right? So you can use these two or these two. And then it's the same going this way. I can either use this point and this point or this point, right? So we're going to have 2 asymptotes. You can use the center and one of these other points. Now again, this got really messy. So for the next one, I'm going to make it less messy and show you all the cool math of it. Does anybody have questions about how I made this rectangle? Right? So I go up and down B, left and right A, and then I make a rectangle out of those things. And I'm going to show you some coordinate geometry next to show you how that affects the coordinates, okay? The dimensions of this rectangle is 2a by 2b. The asymptotes are going to go through the corners, go through opposite corners and the center. So opposite corners and the center. Okay, so that's the concept. Now, we're going to take a look at how the heck to do this. So I'm going to go up and down for this one. Okay, so again, the foci are up here. Okay, so to do this, our center is at HK. Right, our center is at HK, which means this point up here would be HK plus A. And this point down here would be HK minus A. You guys doing okay with that so far? So again, to go up and down, I did K minus A. Now, if I was down here, it would be H plus A, right? So this point right here would be H plus A and K. And this point right here would be H minus A and K. Are you guys okay with that coordinate geometry? Are we doing okay? A sign of life? Like, does that make sense? If it's up and down, that would be the coordinate. Okay. Then over here, this point would be H plus B, K. And this point over here would be H minus B, K. You guys okay with that? And what we get here is we get this triangle, or this rectangle, sorry. Okay, we get this rectangle. So I'm trying to get this coordinate geometry down. Now, if you draw this, if you draw a little image to help you out, you're going to do so much better, guys. Take the time to sketch this, because to find this asymptote, you need 2 points. So we could find both of these, but as you can see, finding this point is a lot of work. So we're going to use this point and we're going to use a point. It could be this point or this point down here. But the whole point is it's going to be both. I'm going to be moving up A and I'm going to be moving right B. So this point would be H plus B and K plus A. Do you guys see how it's both? I both moved up A and I moved right B. Does that help out, guys? Right? So again, down here at this point down here, this would be H plus B K minus A. Right? So if I wanted to find this one, I could use these 2 points. Okay, so I can use these 2 points and I can use these 2 points. Now, that's not to say you can't use this point up here, right? So this point up here would be h minus b and k plus a. And this point down here would be h minus b, k minus a. In fact, you know if it's plus or minus by what quadrant you are. Notice how in the first quadrant, we're both plus. In the second quadrant, we're minus positive. In the third quadrant, we're negative negative. And then the fourth quadrant, we're positive negative. So that also really helps to have a good understanding of the quadrants. Okay, I'm going to hit pause for a second. I have a feeling I'm going way too fast. Are you guys doing okay with this? Are there any questions? Okay, so what's important here is that this isn't something you should ever memorize. I don't have this memorized. What you should be able to do is you should be able to quickly sketch what it looks like and then make a rectangle and to say, I need to find this point. How do I find it, right? And then it gives you a visual aid on how to do it. That's the key. Okay. I ran out of room on my paper. So did everyone get this down? I want to remind you guys how to write the equation for a line. Are you guys okay? Can I move forward? Okay, now there's a couple of ways to write equations. There's y equals mx plus b, right? So this is slope-intercept form. Okay, slope-intercept form is useless. And you're going to find that the further you go on in life, the more useless this is. You're like, wait, but that's all we did in Algebra 1. Yeah, I have no idea why they focus on this. It's the least useful. What's really useful is this. Y minus y1 equals m. Wait, give me a second. Yeah, m times x minus x1. I just derived this in my head. Isn't that crazy? This is called point slope form. This is your bread and butter. Okay, that is the one we want because we have to remember m is y2 minus y1 over x2 minus x1. So given 2 points, use point slope form and slope to get equation of a line. Okay, use point slope form. Don't use this. Ugh. Now, remember, if for some awful reason you have to type it in like this, and I haven't tested it yet, sorry, I'm behind a little bit on my WebAssign assignments. If you can't type it in like this, and I'm like, hey guys, I am 99% sure you can that WebAssign will take this. Like, trust me, it will take this. But if you do, you can always just solve for y. And how do you solve for y? You just go plus y1 to both sides, and there, you're in slope-intercept form, almost. Okay? And then you just have to do some distribution and combining like terms. Okay? So given 2 points, we use point slope and slope to get the equation of a line. Are there questions there? Do you guys remember doing that? By the way, if you guys go on to calculus, bread and butter. Did you guys notice that point slope form is actually just slope, and all they did was multiply both sides by x2 minus x1? What? Yeah. Cray. I wish that they would teach this and not this, but I think we have a lot of teachers that don't know that. Okay. So, that's everything we need to know. Are you guys ready? So let's do we're going to do a bunch of examples together. Okay, we're going to do a bunch of examples together. So here we go. So we're going to write the standard form, what the book calls standard form, of a hyperbola given, so let's see what we're given. We're given vertices okay, we're given vertices, we're given foci, like that. All right, so how the heck are we going to do this? Well, first things first, we need a picture, don't we? Oh my gosh, we need a picture so badly. So I'm going to sketch a picture, and I'm going to give myself lots of room because bigger is better. The biggest graph is best graph. Okay, so let's see here. 0, 2, 1, 2, and 4, 2. 1, 2, 3, 4, 2. So there's my vertices. And then my foci is at -1, 2, and 5, 2. Okay, so I know then that's my major, and it's going to be opening up like this. Terrible graph, but I don't care. Terrible graph, but I don't care. Okay, so we have our foci, and we have our vertices. Okay, so the first step that you always want to do if you don't have a visual, make a visual. Oh my gosh, it's a lifesaver. Kind of looks like a bat, doesn't it? Kind of looks like a bat. I don't know if that's what they were going for. All right, so we need to find everything that we're going to do. So the next thing I might do to be a little bit motivated, I might be like, okay, my major is definitely on the x-axis. So I can go x minus h, quantity squared over a squared. It's a hyperbola, so it's going to be the difference. So I have y minus h quantity squared over b squared equals 1. So we need to find our center. We need to find A, and we need to find B. Now, notice we can't find B from the information given. So that means we're going to have to find C and then find B through that equation on the side. And then I'm trying to go slow. Do you guys have questions or anything? Right, so we need to find the center. We need to find A, B, and C sometimes. Okay. So how are we going to do this? Well, we know that the distance from our center to the vertex is A. So if we take a look at our vertexes and we count, it's 1, 2, 3, 4. So that's going to be 2. Nope. So this one. Oh, I put H's on both of them, didn't I? I'm focusing on bigger things. Thank you for getting that small detail. Yeah, that's okay right there. Okay. All right, so we know the distance from our vertices is 1, 2, 3, 4. So that's 2A, right? So that means if double my A is 4, that means one of my A is 2. So if I go 1, 2, that should be my center, right? Because it's 1, 2 this way, it's 1, 2 this way. So I know then that my center is going to be 2, 2. Okay, so again, I found my center because it gives me both my vertices, and I know that my center is going to be halfway between my two vertices. Okay, which means my A equals 2. So now I'm going to have to find my B and my C. So I can't find my B. So this is A equals 2. And then my C is going to be the distance from my center to my focus. So I'm going to go 1, 2, 3. So my C equals 3. So I'm going to have C equals 3. So I'm going to solve for B because I know C squared equals A squared plus B squared. I'm glad that I got that down. I didn't put it in my notes. Bad, Mr. Kraft. So what do we have here? C, so this is 3 squared equals 2 squared. So I'm going to have 3 squared minus 2 squared equals B squared. And I'm going to take the square root of both sides. We're going to ignore the negative here because we're talking about a distance, right? So we're going to ignore the negative answer here because we're looking for a distance. So what is this? This is 9 minus 4. And of course, you guys can skip. I'm showing all of my work. 9 minus 4, what's that? That's 5. Okay. So the square root of 5 equals B. All right. So this is the fun part. Are you guys ready for the fun part? Okay. So square root of 5 is approximately, it's a little over, so square root of 5 is a little over 2. I could have done that without the calculator. So let's go ahead and let's set up our box. So I know my center is at 2, 2. And I know the box is going to go right A, left A. And then to go up, it's going to go up root 5. So it's just a little over 2. So I'm going to go 3, 4, 5. And I'm going to go down 1, 2, 3. So I know I'm going to go up a little over 2. And I'm going to go a little down over 2. And I'm going to get this rectangle. So this is 2, 2 plus root 5. And this is 2, 2 minus root 5. Like that. I mean, I'm finding the equations for the asymptotes. So we could go ahead and solve this. Here, let's go ahead and solve this, right? So 3. So now that you have everything, you just type it in, right? So this is my H, this is my K. So I'd have X minus 2 quantity squared over 2 squared is 4 minus Y minus 2 quantity squared over B squared, which is 5 equals 1. Sorry, I ran out of space there. Okay, so that's, I mean, finding the equation is just like finding the ellipse. I want to spend time figuring out how to find these asymptotes. So I'm going to hit pause there. You guys okay with finding the equation? Did I go too fast? I'm so used to going through these problems fast because they're so long and I don't want to spend a lot of time on them. Okay? So again, this is a lot like ellipses, right? The only difference is the equation has a minus in it, right? So just remember when you plug the A back in and the B back in, it's A squared and B squared, not A and B. So my A is 2, so when I plug it back in, 2 squared is 4. And my B is square root 5, but square root 5 squared is 5. Okay? So there's that. Now we're going to find the asymptotes. Okay, and so to do that, we have our center. Our center is at 2, 2. So I'm going to need 2 more points. So I'm going to choose, because I can, because I feel like it, I'm going to choose this point and this point. Because I'm feeling like I want to be right. I want to be right. So I'm going to pick those 2 points. So I'm going to find the coordinates for these. So this point in the upper right, I'm going to be adding A and I'm going to be adding b. So it's going to be 2 plus a, which is 2, and it's going to be 2 plus root 5. So I would write this as 4, 2 plus root 5. Okay, so there's one of my points. That's this point right up here. Okay, that's this point right up here. 4 and then 2 plus root 5. This point down here, I'm going to be adding a and subtracting b. So I'm going to take a plus a, which is, right, a plus a, and then the y minus b. So I'm going to have 4, 2 minus root 5. Okay, and that's this point right here, 4 and then 2 minus root 5. So there's going to be 2 asymptotes. So again, I'm going to use point slope form. So the first thing I'm going to do is I'm going to find slope. I'm going to find this line going up and down, or from left down to upright. So positive slope. So to find my slope, I'm going to use this point and my center. My center is going to be x1, y1, because it's the leftmost point, and this is why I did both of them the same on the right, so that this one is always my first point. It's x1, y1. So then this becomes x2, y2. So I'm going to do y2 is 2 plus root 5 minus y1, which is 2, over x2, which is 4, minus 2. So my slope then, the 2's go away. I get root 5 over 2. Okay. So to go write my equation, I'm going to have y minus y1, which is 2. My slope is root 5 over 2, and my x1 is 2. So bam, there's my equation for one of my asymptotes. It was literally that easy. Okay, so again, you use your center as your first point, you use one of your new points as your second point, and bam, you have your equation. The hardest part is finding the slope, right? The slope is y2 minus y1 and x2 minus x1. How are we doing there, guys? We doing okay? We're going to do another one of these, so don't worry. We're going to do one more. Okay, so then my second one, so I'm going to have my second slope, right? And this should be a negative slope because I'm going to be going down. So my y2 is 2 minus root 5, and then my y1 is 2. Oops, minus 2. And then all over, my x2 is 4, my x1 is 2, so the 2's are going to cancel out. So I get negative root 5 over 2 is my slope. So that means my equation for this line is y minus 2 equals negative root 5 over 2 x minus 2. So that's how you find your asymptotes. Because on your homework, it's going to ask you to find your asymptotes. It's going to ask you to find the equation. And then we're going to do one here in a second is where I'm going to give you in polynomial form. You're going to have to complete the square and find everything. So it's a lot of the same stuff we have been doing, but the equation is slightly different. Oh my gosh, I feel like this lesson is a lot. Are we doing okay? I only have 10 minutes. That's ridiculous. Remember, guys, I get it. This is ridiculous that we're doing this in 50 minutes. Okay, so please come to my office hours if you need help. Okay. Am I going at an okay pace? You guys doing okay? It is a lot. It is a lot. So just remember, isn't this stuff new? I mean, this stuff is like the same, right? It's right. You just got to remember new equation, and then the asymptotes. You're just using the picture. You're just using coordinate geometry, right? Just think of it this way. You already have the skills to do this. It's just new. Like you already have the skills to be able to figure out these coordinates. You already have the skills to be able to figure out this line. It's just let's brush some rust off of it. And it's going to take time, right? Look at this. We did one problem and we're almost done. So it's time consuming. Again, why we broke it up into 2 lessons. Okay. All right. So for this next one, it's going to be a little bit different. So this one is going to be, we're going to have 4x squared minus 3y squared plus 8x plus 16 equals 0. We're going to find everything. Okay, and obviously the problem's not going to say that in the book. What I mean is you're going to find the vertices, you're going to find the foci, you're going to find the asymptotes. Okay, so we're going to find everything. Okay, so remember to do this, the first thing we're going to do is we're going to want to get this into conic form. And then once we're in conic form, we're going to draw an image to help us find everything. Okay, yeah, it's slow moving and there's a lot of steps, but you can do this, guys. You can do this. If I can do this, you can do this. Okay, that I know for sure. So I'm going to get this. I'm going to have to complete the square twice. So I'm going to group my x's together. So I have 4x squared plus 8x. The difference here now, see how I have a minus with my 3y. And hey guys, when you're doing this, just a pro tip here. When you're doing this, be really careful. The negative has to come second. Order matters. Okay, I can't stress that enough. The negative has to come second. And the reason why, remember, it's the absolute value of the difference. So when we're writing this, order matters. It has to be the bigger one minus the smaller one. So with the negative being with the y, we already know the major axis is going to be with the x. Okay. You guys okay with that? Does that make sense, guys? The negative matters? All right. So I'm going to complete the square. So I'm going to have 4x squared plus 2x space minus, and then here it's just y squared's already in vertex form. It's y plus 0, right? So it's just 3y squared. So we don't need to complete the square here. This is already in vertex form. Does that make sense? Right? I could do this, right? Do you guys want me to do that? Or do you guys get that this is already, right? So you take half of 0, and then I'd have 0 squared to both sides, and then I'd go y minus 0. You guys okay with that? You guys see how it's just y squared, so it's at 0, 0? Okay, just want to make sure. Here, though, I'm going to go to this, so I get b equals 1. I'm going to add b squared here, which is going to be plus 1. But this is really 4 times 1, so I'm going to add 4 times b squared. So that's 4. And then here, I just add 0. So what do we get? We get 4 times x plus 1 quantity squared minus 3 times y squared. Now remember, I can go y minus 0, but we're lazy, so we don't do that, right? So I could put y minus 0. If that helps you out, do it. Okay? And then here, negative 16 plus 4, that's negative 12. Oh my gosh. I think, you know what? I just got bamboozled, didn't I? This negative 12 here, that's going to make this positive, isn't it? And the y, it's actually going to be with the y. Oh my gosh. I got bamboozled super hard, didn't I? The y is going to be the major because this is negative. Oh my gosh, crazy times. So I'll just rewrite it when we get there. But hopefully you guys notice when I divide by negative 12 now, that's going to change the sign of things, right? So just really quickly, that's going to go to change to positive. 3 goes into 3 once. 3 goes into, or negative 3 goes in here 4 times. What do we got here? 4 goes into 12 3 times. So I'm going to switch these because you see how now this is going to be negative and this is going to be positive. So I'm going to get y squared over 4 minus x plus 1 quantity squared over 3 equals 1. And notice here, right? The 4 is definitely the bigger number, right? Because a is going to be 2 and b is going to be square root of 3. Okay, so there's my equation. So again, I want to write the positive one first. Okay, so let's go ahead here. My a is going to be 2. My b is going to be square root of 3. My center is going to be negative 1, 0. Am I going too fast? Sorry. You're welcome. Thank you for asking. Appreciate it. Okay. Are we doing okay so far, guys? So this is the information right down here. This is the information that I can get from the equation. We need to draw a graph because we're going to get everything else from this. So I'm going to go like this, make it nice and big because like paper, right? Who cares about the environment? Okay. That was sarcasm. My center is at negative 1, 0. So here's my center. I see here that my major is with my y. So I'm going to go up 1, 2. And then I have a vertice. And I'm going to go down 1, 2. And I'm going to have another vertice. Okay. Ooh, my nose. Okay. So it's going to look something like that. And okay, and again, I'm just guessing. Look something like that. Okay. Now I'm going to need C to find my focus. So to find C, I have C squared equals A squared plus B squared. So that is C equals the square root of A squared plus B squared. So I already have A squared and B squared. I already have A squared and B squared, right? It's 4 and 3. So my C is going to be the square root of 4 plus 3. 4 plus 3 last time I checked is 7. So C is going to be the square root of 7. Because square root of 7 is irrational. Okay, so that means my foci, right? So square root of 7, let's see, 4. So it's a little less than 4, right? Square root of 7 is a little less than 4 because 4 times 4 is 8. So I'm going to go down 1, 2, 3, 4. So a little less than 4. There's my foci. It's a little less than 4. So 1, 2, 3, 4. A little less than 4. There's my foci. Okay, so a little less than 4. So I can write those down now, though. So let's write this all down. So my center's here. My vertices. I should go like that. My vertices. So it's going to be my center up 2. So negative 1 up 2. And my center down 2. And then my foci, it's going to be my center down root 7. So negative 1 minus root 7 and negative 1 plus root 7, like that. So be careful. This is already squared. My a is 2. So 2 squared is 4. So this is a squared. Right here, this is a squared, and this is b squared. So my a squared is 4. Right? So in the equation, this is my a squared, this is my b squared. So my a is 2, so 2 squared is 4, and root 3 squared is 3. I hope that makes sense. Thank you for trying to show that though. But yeah, just be careful here, right? Because this is a squared. So your a squared is 4, your a is 2. All right, and then to find the asymptotes, right? Or asymptotes, right? Tots, goats, totes. I'm going to remember that if this is my center, my b is root 3. So root 3 is less than 2. So 1, 2. So it's like here. So 1. So it's like right here. Again, I like to pick the points to the right because it makes it a lot easier for me. So I'm going to find this point and this point. Okay, so if my center is at -1, 0, I'm going to add my a, I'm going to add my b. So that means -1 plus 2 sorry, my a is up, right? My a is up, so this is my a, this is my b. So my a is 2, and my b is -1 plus root 3. So this is -1 plus root 3, and then it is up 2. And then this one is -1 plus root 3, and it's -2. Okay, so those are the 2 points that I'm going to use to help me find my asymptotes. So, oops, I'm a little over, guys. I'm sorry about that. So to do this, remember slope. So I'm going to do this one first. So let's call this line 1. So the slope of my first one is y2 minus y1. y1 is 0. And then x2 minus x1, so minus a -1. So when I do this, 2 minus 0 is 2. The -1s go away, so it's 2 over root 3. Now I have to double check. It may not like it to have rationals on the bottom, but to do that, you can just multiply by root 3 over root 3. And then while I'm at it, why don't we go ahead and find our second line. So let's call this line 2. So the slope of line 2, again, is going to be y2 minus y0. And then it's going to be x2 minus x0, or x1, sorry. So I get -2. Those go away over root 3. Okay, and just really quickly, that would be -2 root 3. So -2 over root 3 would be the same as -2 root 3 over 3. Okay, so my asymptotes, when I go to write these, it's going to be y minus 0 equals 2 over root 3 times x plus 1, and y minus 0 equals -2 over root 3 x plus 1. Okay. Holy moly. So I'm supposed to be done at 12:10. It's 12:14. I'm so sorry for taking your time. A couple of last announcements I want to say. You have a short, this is a short assignment. 1, 2, 3, 4, I think it's 5 problems. Only 3 of them do you have to do all of this stuff. If you need help, please come see me in my office hours. All my office hours are in the morning. One other thing I want to point out is that our final is going to be posted on 310 and due on Friday by noon. And I'll remind you that as we're coming up. So just remember, if you're looking at still getting your grade up, the ways to get your grade up is make sure you have no missing assignments. 2, there's the review for the midterm. That's worth extra credit if you have more points than your current grade. And then there will be a review for a final posted before next class, and that also will be worth extra credit if you get better on it than your current grade. Okay, so those are all ways of getting your grade up at this point. Okay, again, sorry for taking more time.